Welcome to this online revision session for AQA FP1, in which we will be looking at the solution to the June 2011 question 5, which covers the topic of the general solution of trig equations. In this question we're given cosine of 3x take away pi by 6 equals root 3 over 2, and we're firstly asked to find the general solution in terms of pi. Remembering here we're working in radians, it's then useful to consider the shape of the cosine graph, which we know starts from 1 when the radians are 0, and then goes through to 2 pi, and because this is the cosine graph we know that there is a reflection of this, a line of symmetry going in the opposite direction. So firstly we need to find out the value of the angle when the cosine is equal to root 3 over 2, and we should know that is one of our standard angles that we know, and we need to know that that is pi by 6 and 30 degrees. Remembering though we're working in radians, and by symmetry we therefore know there will be a similar value at minus pi by 6, and that these two solutions will then be repeated every 2 pi, and so this will generate our complete set of solutions. So we can start off by saying that 3x minus pi by 6 will be equal to either plus or minus pi by 6, and then since it's repeating every 2 pi we can add on multiples of 2 pi, 2 pi n, where n can be plus or minus an integer value. Now we can find out what x equals by rearranging. So if we add pi by 6 to both sides, we get pi by 6 plus or minus pi by 6, plus again our multiples of 2 pi. And then if we divide through by 3, we get pi by 18 plus or minus pi over 18, and then we've got to divide the 2 pi n by 3, or we can write that as 2/3 of pi n. So there is our general solution to this particular equation. Now there were 5 marks allocated in this part. Well, for you to identify that pi by 6 is the value that the cosine will be equal to root 3 over 2, stating that somewhere will give you 1 mark, or the fact it's been used. The fact also then that you identify that minus pi by 6 is also a value of significance to you, will give you 1 mark. The fact you introduce the 2 pi n will give you a method mark for writing down that solution, and then going through to obtain a value for x gives you a similar method mark, and then finally for having the correct form, the correct solution in radians will give you an accuracy mark. At this point, if you happen to have done the whole thing in degrees, at this point you would have lost that accuracy mark. Okay, well that's part A completed. Next part, in part B, it's now asking you to use your general solution to find the smallest solution for which the solution is greater than 5 pi. Well, it's probably helpful to rewrite this solution, general solution, as some sort of overall fraction of 18 to help you find this. So if we take the 18th out as a factor, we've got plus, and then the 2/3 will end up being 12 pi n, and we want the smallest solution for which that's greater than 5 pi. So 5 pi we know is going to be 90 pi over n. So this second part here needs to be over 90 pi to give us an appropriate solution. So we can see that if we put n as 7, that would only give us 84 pi plus or minus a bit. So n will have to be 8 to give us the appropriate value. So if n is 8, we can see we're going to get 8 12s and 96. And then the smallest one will be pi minus the pi there for that to cancel out. So this will give us a solution of 96 pi over 18. And if we divide through by 6, that is going to give us 16 over 3. Lots of pi. So again, the 2 marks for this part will be identifying that n has to be 8 will give you 1 mark, and then for an accuracy mark for obtaining the correct value of x will give us the 2nd mark that you require. Well, hopefully you found that solution helpful. For more support with your maths revision, please go to the Further Maths Support Programme website.